We were just talking about similar triangles at the bottom here. We said similar triangles have congruent corresponding angles, but their sides, we were looking for the word. They are not the same, right? But if I took each of these three sides and multiply them by 2 or 3, I'd get my new triangle, which means that the sides are, there's a certain word I'm looking for that begins with a P. Yes, proportional. That's the word. So, and proportional corresponding sides. That's a big help to us because we can use similar triangles to solve all sorts of interesting problems. So if you flip the page over, we have a problem here. Let's see if we can figure this one out. Joey wants to know the height of a tree in a park near his home. The tree casts a 38-foot shadow at the same time that Joey, who is 63 inches tall, casts a 42-inch shadow. Find the height of the tree. Okay? So you may have done a problem like this in the past. What they basically have here are two similar triangles. I actually don't even like that diagram at all. I'm just going to make my own. I don't like that the ground's not the same. So like Joey's standing up here and the tree's down here. That makes no sense. So there's the ground. I'm going to have some tree. I am like an expert artist, so prepare to be bedazzled. All right, I'm trying to figure out how tall this tree is. I have no idea. So I'm going to call that X. But I do know that the tree casts a shadow, which it says is 38 feet. That's important, right? Then I have Joey, whose height is given in inches. So here is Joey, 63 inches. He also has a shadow, and his shadow is 42 inches. So before I even begin, what should I do? Anybody know? Yeah, it's probably a good idea to be in the same units. In this problem, it actually won't matter, but if we had pieces and other ones, it's never a bad idea to just be all in the same units. So if I change 38 feet into inches, I get 456. Okay, now there are some things that we need to know about these triangles. So some assumptions that we make are that the tree is growing perpendicular to the ground. Okay, and we're also assuming that Joey is standing perpendicular to the ground. So those are pretty safe assumptions. I know trees don't always grow perfectly, but we're assuming that it's perpendicular to the ground. And then the other thing that makes this work, do you remember from geometry how to prove that two triangles are similar? Because not all triangles are similar to each other. Anybody remember something you had to do? If you can get two angles in the triangle to be the same, the triangles are similar. So you have one, the 90-degree angle, and then it turns out that this angle is also going to be the same. Well, so is this one too. But the reason why this one's the same, this is so cool, right? These diagonals here, the hypotenuse, is really formed by the rays of the sun, right? That's how I create a shadow. I'm blocking out the rays of the sun. The rays of the sun, when they enter into our atmosphere, this is so cool, are parallel to each other. So what you essentially have right here are two corresponding angles, right? Look at that. There's my transversal. I have same seat, different table. If I just pick this up and moved it here, it'd be right there. So I have a pair of corresponding angles that are the same. So anywho, that's why I can do this. Now that I've established that I do in fact have similar triangles, which by the way, the symbol is that, if you didn't remember. It's just the squiggle without the equal bar underneath. So that just means similar. Once you establish that you have similar figures, you can use a proportion to now solve for this missing side. Do you remember doing that? Maybe? So you can set up a proportion. Maybe you do something like x over 456 equals 63 over 42. Yeah? x over 456 equals 63 over 42. And then do you remember how to solve a proportion? Maybe? Yep, you can cross multiply. So I'll get 42x is equal to whatever 456 times 63 is. 28,728. Divide by 42. I get 684. What unit am I in? I'm in inches. They don't specify if I wanted feet or inches, but just out of curiosity. Let's see what it is in feet. 57. All right, so does that kind of ring a bell, doing problems like that with similar shapes? Once you establish that you have similar figures, you can use a proportion to solve for any missing sides. Okay, so that's pretty much it for 1-2. So